Hi everyone, welcome to Food for Thought Chemistry. Today we'll be discussing redox, reduction, and oxidation. So what is redox? As you can see, I've written here that the loss of electrons is oxidation and the gain of electrons is reduction. But what does this mean? An electron has a negative charge, so if you add electrons to an atom, its overall charge will be reduced. That makes sense. But why is the loss of electrons oxidation? Oxygen is a highly electronegative atom and will often take electrons away from other atoms in a covalent situation. Oxidation does not always involve oxygen, but it is the most common way to do things. So, as you can also see, I've written that if the oxidation number goes up, it's oxidation. If the oxidation number goes down, it's reduction. So, what does this mean? What is oxidation number? So, say we have a molecule like H2O. And we have two lone pairs around the oxygen. What this means is that if we have a pair of electrons, the hydrogens will each have a +1 oxidation number because the oxygen will essentially take their electron away from them in a covalent bond, and which means that the oxygen will have taken these two extra electrons away, so it'll have a -2. Note that the other hydrogen also has a +1, so the sum of the oxidation numbers is going to add to 0. And this is always true in a neutral molecule. So if we have something like NH3, each of the hydrogens will have +1 again because the nitrogen takes it away. And then the nitrogen will then have a -3 because it's taken the 3 electrons from each of the hydrogens. So again, it adds to 0. Rules of thumb include that H is almost always +1. In some situations, it will be -1, like in NaH, simply because Na really doesn't want your extra electron since it's all the way over on the left. O is almost always -2. It will take 2 electrons away. And then fluorine, chlorine, bromine, etc. are almost always going to be -1 because they're super duper electronegative. They will take that extra electron. So now we can see how this plays out in an example reaction. So say we have the reaction of methane and oxygen to form carbon dioxide and water, which is, a very common reaction on Earth. We have a lot of combustion going on. So first thing we need to do is balance the reaction. We're going to do this by adding a coefficient of 2 to the H2O. And then we're good to go. If we have 2 oxygen molecules. Now, we know that each of the H's in CH4 has formal charge +1, so the carbon will have -4. Any atom, when bonded to itself, has 0 formal charge. And then, again, here in CO2, the carbon will have +4, and each of the oxygens will now have -2. And then the hydrogens will have +1 still, and the oxygen will have -2. So you can see here that the oxygen gets reduced and the carbon gets oxidized. And this shouldn't be any surprise. The carbon is being bonded with oxygen, so it's no surprise that it gets oxidized, and the oxygen gets reduced. So a general rule of thumb is that oxidizing agents get reduced, and vice versa. This concludes our basic discussion of reduction and oxidation reactions. Next time, we're going to be applying this to the chemistry of acids and bases. See you then!